And we're going to begin with question 3 out of 2.4. Okay, so question 3, we've got an inequality, and we also have the graph already drawn. Okay, so that's what we've got on that one. Now, we already have the line, so we don't have to worry about that component of it. All we need to do is figure out if we shade above or below the line. How do we do that? Well, we pick a point that is clearly not on that line. So a nice easy point to start with is going to be 0, 0, because 0, 0 is right there. Okay? Clearly not on the line. We label it so we know where it's at. It's above the line. So now we're going to check 0, 0 in our original. And the good thing about 0, 0 is it's so easy to work with, especially when something's in kind of a standard form like this. And so the left-hand side comes out to be 0. And then is 0 smaller than 12? Yes, 0 clearly is smaller than 12. So that is clearly true. So that means this half is true. And where do we shade? We shade the true half, which is going to be over here, because that half is true. And that's all that you need to do for question 3, because the graph has already been drawn, or the line's already been drawn. So then we just shade. 5, I believe we have to do it all. Yep, 5 we have to actually draw the graph and then shade as well. Now, for 5, we need to remember if we have a solid or a dotted line. So greater than or equal to, less than or equal to, those get a solid line. Strictly less than, strictly greater than, those get a dotted line. Okay, so when we look at this one, 5 is clearly going to get a solid line. So let's remember where we begin. So for question 5, we have 2x plus y is less than or equal to 4. Okay? Now, we're going to be checking our ordered pair in this. So I'm going to put a box around it so we don't lose it. So that's what we're going to have to check everything in. But let's replace that inequality with an equal sign so we can graph it. So we'll replace that inequality with an equal sign. And then we want to graph it, so we have to solve it for y to get it in slope-intercept form. Bless you. Okay, so what we did was we just replaced that inequality, bless you, with an equal sign. And now we can graph it because it's in slope-intercept form. So our slope, m, is a -2. And our y-intercept is going to be 0, whatever number's on the end, which in this case is a 4. Now we can graph it. And we're going to be using a solid line. So we're at 0, 4. Okay, that's going to be up 4 units. And our slope is a -2. So that's a -2 over 1. So we go down 2 and over 1. So down 2 over 1. So that would be right about there. And that would be at about 1, 2, if you want it as an ordered pair. Okay. Connect them together with a solid line. And there's your line. Now, are we done yet? No. Okay, because this is an inequality, there's one more step. So we have the line graphed. We now need to check our shading. So we're going to check 0, 0, which is right here. There's your 0, 0. And we're going to check that back in the original. So that gets checked back into this. And as you can tell, it's very, very easy to work with. If I plug 0 in for x and y, that makes the left-hand side 0. And is 0 going to be smaller than 4? Is 0 smaller than 4? Yep. So that would make that then true. Where's our 0, 0? It's below the line. So this half is true. And where do we shade? True sign, which means it looks like that. Okay. Now, when I go to grade these, what am I looking for? Well, I'm going to look to make sure that the graph goes down from left to right. Very important on that. That you start at about 4 and that you make sure you shade it below the line. Also make sure it's a solid line. So those are the things I'm looking for. It doesn't have to be a perfect graph. All I'm looking for is make sure it goes down. Make sure that slope is negative. Make sure it starts at around 4. And make sure that you shade below the line and it's solid. I'm not expecting perfect graphs. Graphs are just sketches. If we wanted an exact graph, we would use a computer to get a much better picture. But this is just a hand-drawn sketch. 9 is very similar to 5. Well, sorry, to 3, because in question 3, we already had the line. Okay, so 9 looks like this, and we've got 2x plus 4y is less than or equal to 8. And all we need to do, we've got our line drawn here, all we need to do is figure out if we shade above or below. And so how do we do that? We pick a point that is not on the line at all, which in this case is 0, 0. Okay. Very easy to work with because the left-hand side is already 0. And if the left-hand side is 0 going to be smaller than 8? Yep, it is. That would be true again. Okay, so that means then this half is true. The other half is false. 0, 0 is below the line. It is true. So where do we shade? We shade below the line. That's it. Question 10, we're going to have to completely draw the line. But it's no more difficult. So x minus y is less than a negative 4. Well, this one is going to have to be represented by a dotted line, right? Because it's strictly less than. Now, I always like to box this so I know what I'm doing, so I don't lose it. It's easy to lose track of things. I'm just going to box that inequality so I know where it's at. Because we're going to be checking probably 0, 0 in there. If 0, 0 doesn't work, if it's on the line, you'll pick a different point. But in this case, it'll be on the line. And we just simply replace that with an equal sign. Move our x over. So minus y equals a minus x minus 4. We switch our signs by dividing by that negative 1. And then we get in slope-intercept form now. Negatives will start canceling. We get an x. And negative makes it a positive 4. So my slope is 1. And my y-intercept is going to be 0, 4. And all we have to do is graph it. We use a dotted line again. We start at 0, 4. Okay. Slope is 1 over 1. So up 1 over 1. Up 1 over 1. So that's going to make my second point right about there. So 0, 4, we're going to go up 1. So that makes it 1, 5 or thereabouts. You don't have to label the ordered pair. All you have to remember is go up and over. So up 1 over 1, make a dot. If you want to label it, you can. I'm just labeling it so it's easier, but you don't have to do that. You can just count units. Now, we know we have to have a dotted line. And we've got to check a number that, or sorry, an ordered pair that is not on this line, and that'll be 0, 0. We check it back in the original, and is 0 smaller than a negative 4? Is 0 smaller than a negative 4? In this case, no, that is false. 0 is bigger than negative 4, right? So that means the lower half would be false, the upper half would be true, and what does it look like? Where do we shade? Upper half, which is up here. Now again, I'm not going to be super picky on the graph. What I'm going to be looking for is I want to make sure that that line is going up from left to right because your slope is positive. I want to make sure you start roughly at 4. I want to make sure it's a dotted line and that you shade it above. So those are the criteria that I'm looking for. If it's a little bit steeper than mine, that's okay. I just basically want to make sure that it looks something similar to that. So those are the inequalities. Next, we're going to talk about 2.5, which is the functions. And these are pretty easy to work through. They don't take a long time. Okay, it's just a matter of understanding what I'm looking for in 2.5. Once you get the idea, 2.5 is very quick on most of them. So we're going to begin with question 1. Okay, now, first off, we need to see if this is a function or not. Now, when we talk about functions, it has to be able to pass that vertical line test, which means we draw vertical lines, we see if there's anything that connects it above and below. Now, when we look at these, see these points, there's no point directly above it, right? On this one, nor this one, nor this one. So it would be a function. And you can also think about it as ordered pairs. Every x component is different. Right? So that makes it a function. If there was a point right here at the end of the pen, then that would make it not a function because it would fail the vertical line test. So we look at these, there's no point directly above or below each point. So in this case, it would be a function. Then we need to give the domain and the range. Now the domain is going to be related back to the x values, and the range, sometimes called the target, goes back with the y value. So if you use a different textbook, you might see target instead of range, but they're the same thing. So domain is the values of x. So I look at each ordered pair, and we're going to write down the x values. Remember, x goes first, y is the second component. And we usually try to write these with the smallest x value first. So my domain would be a -3, a 0, and a +6. Those are your x values. The range is going to be your y components. And we only write duplicated values one time. And so we look here, we've got our smallest value, which is a -3 for the y, and then our other value is a 4. So my range would then be -3 and 4, because the y values are here, and that 4 is up there as well. So it is a function. Why is it a function? Because there's nothing above or below these points. If there would have been a point right here, it would fail the vertical line test, right? But there's not, so that means it is a function. You could have also just wrote these out as ordered pairs, looked at them like you would do on questions 5 through 9. It's the same thing, it's just it's a picture. Question 4. Question 4 is an ellipse. And I'm guessing that where we struggled at was probably determining the domain and the range. It's pretty easy to see on 4 that it's not a function because it's an ellipse. Ellipses and circles are not functions. Okay, let me make sure I label this one pretty close here. So that looks like that's about -5. And that's about 6 over here. Okay, and then that looks like that's about -4. And about a -6. Okay, and I'll try to draw this the best I can here. You've got a better picture, but at least this will work for what we need here. Okay, and you got a much better one than what I've got, but I did label it so you can see where the pieces are. Now, first off, it's not a function. Why is it not a function? Well, it's not a function because it fails the vertical line test. If I draw a vertical line right through there, that will touch the graph at 2 places. And that means it's clearly not a function. Most of us probably did not struggle with the function part. Where we struggled with was the domain and the range. And the domain is the values of x. So I went ahead and labeled these on the x-axis because here's your x-axis. And where does this ellipse go to on the x-axis? Well, working from left to right, it looks like on the x-axis, it's at -5, and where does it end at? On the x-axis, looks like it's at +6. So your domain would be square bracket, -5 to +6. And the range is the up and down part. And I was pretty careful when I looked at the picture. It looks like that's at 6 there. Oh, it might be at -4. Yep, I may have counted. Yep, that might actually be -4 there. Sorry about that. When I re-looked at the picture, I know it's hard to tell, but that looks like that's at about -4. Yep, looks like it's about -4. Okay, so it's going to be about -4 to +6. What about the range? Well, if I look at the range, that's the up and down part, and that's going to be this piece right here. And where's the range going to be from? We always start with the smallest value, which is -6. And where does it end up at? On the y-axis, it looks like it ends up at about -4, doesn't it? That's your y component there. So it's pretty easy to see that it's not a function because it clearly fails the vertical line test. Domain is x, so I went and labeled it. And it looks like it's, if you said -5, that's okay too, because it's hard to count dots on this picture, on the graph here. But it looks like it's at about -4 to about 6 or thereabouts. And then this is going to be up and down between -6 and 4, -4. Very important that you write the smallest number first. So don't write this as -4, -6, because that wouldn't be correct. You always think about the number line. And you always write your smaller value first. That's the way we write them, because these are actually on the number line. Question 8, ordered pairs. Now, what do we know about ordered pairs? Well, ordered pairs are functions if the x values are different, right? If all x values are different. So when we look at 8, we've got some ordered pairs. We've got -8, 2, -8, +8, -1, -3. We've got 4, 3, and we have 8, 3. Now you can just look at these and list out the x values and the y values. I like to make a picture. Okay, I like to make a mapping. This is called a mapping, where I'll map the x values to the y values. I think it's just easier to see. This is just a visual way of looking at it. It's a mapping. So x goes first, so -8 maps to 2. -8 also maps to 8. -1 maps to -3. 4 maps to 3. And 8 also maps to 3. Can someone tell me if this is a function or not? Yep, it's clearly not a function. Why is it clearly not a function? Yep, we have a duplicate x value right here, and we can't have that because that would fail the vertical line test. If I drew those points, they'd be on top of each other. So we can see clearly from our mapping that it's not a function. And now we just find our domain by listing out the x components. And we always begin with the smallest and then work our way up. Duplicate values are listed once. So -8, -1, 4, and 8. And our range, which is the y values again, always want to begin with the smallest value. Think about a number line. So -3 is our smallest value. And then it looks like 2, +3, and 8. So that would be your domain and your range there. Is everyone okay with that? So pretty simple on these. Not difficult at all. It's just a matter of understanding the terminology. Much simpler than that 2-3. 2-3, I think, was the most difficult, where you had to find those equations of lines. Those are the ones that students always make an algebraic mistake on. But this is more of a concept type of question. 3 more of these. So we've got 10, 13, and 15. So question 10. So this is an equation. Now the function part is the easiest part. You shouldn't have any trouble at all determining if this is a function or not. You can just look at it and tell. How do I know if something's a function? It's a function if it can be or it already is solved for y. Well, it's already y equals, right? So clearly this is a function. That's the easy part. What about the domain? Now, when we talk about these equations, we're going to look at the domain. Now, there are a couple of scenarios. It can either be negative to positive infinity, right? We might have division by 0 and have to work with that, or we might have to work with square roots and an inequality. Now, this one has a square root, and so we're going to have to work with an inequality. Why do we have to work with an inequality? Well, we're plugging values in for x, and you cannot take the square root of a negative number, right? It's undefined. In college algebra, you'll learn that that's actually a complex number and got an imaginary component. But in this class, we can't take the square root of a negative number. It doesn't exist, right? It's not a real number. So we need to make sure that this never ever goes negative underneath, because if it goes negative, we can't take that square root. So what we do is we set what's under the root greater than or equal to 0, which is simply 3x minus 7 greater than or equal to 0. And now we're left with an inequality that we can just quickly work through. So move things around. Add your 7. 3x is greater than or equal to 7. Divide by your 3. And we now have x is greater than or equal to 7/3. I like to put them on a number line. So here's my 7/3, pointing to the right. So we shade to the right. We use a square bracket here. And now we can get the domain. And the domain comes directly off the number line in interval notation. So in this case, the domain would be 7/3, right? Because that's what comes here. And where does this go to? Positive infinity. And infinity always, no matter what, has parentheses. So if you have a square root, what do? Take what's underneath that root, set it greater than or equal to 0, and solve that inequality. Okay, 13 is a little bit different. Okay, now 13, is 13 going to be a function or not a function?
No.
It's not a function, right? Clearly not a function. And why is that not a function? Right, it's not solved for y, it's solved for y to the 6th. Then we can't have that. It has to be y by itself, not y to a power. So it's not a function. Now, if it's not a function, we find the domain by checking values of y, and we see what we get out. So it's not a function, so we're going to have to check values of y. Now, I usually use 10 and negative 10. You can check it implicitly with y and negative y. Students struggle with that, though. So let's just check y equals 10 and y equals negative 10. Now, I'm not so concerned about the actual value. All I really want to know is it positive or is it negative? We can calculate out the value, no problem, but the important part is the sign. So if I plug in y equals 10, well, 10 to the 6th, just by looking at it without even using a calculator, you can tell that that is going to be what? Positive, right? Okay? Because positive number to a sixth power stays positive. What about negative 10 to the 6th power? Well, if I plug in negative 10 to the 6th power, is that going to stay positive or become negative? Which one do you think it'll be? Positive or negative? Yep, it'll be positive. Why? Because if we write it out 6 times, and then you cancel signs out, you can see these two cancel, make that positive. Those make it positive. Those make it positive. And so then that becomes positive. Now, what are we getting out? We're only getting out positive values, right? Both sides are positive. So what does that tell me about the domain? We can't get any negative numbers out, right? Only positives or 0. So what's my domain? Okay, my domain is only positive values are 0. So it's 0 to positive infinity. Because you get out only positive values. Or 0, because 0 to the 6th power stays 0. So that's your domain. I'll go ahead and mark it just so we don't lose it in the work here. And this is clearly not a function. When they're not a function, you have to check your values. One more, and then we'll look at the next section. What we'll probably do is we'll work through the next section, take a break, come back, and then look at the practice exam, because we've got a lot of questions on that practice exam. So we'll finish this section and the next section's questions, and then we'll take a short break and work on the practice exam some more. Question 15. Is this a function, yes or no? Okay, yes it is. Now, when we talk about the domain, the domain is negative to positive infinity unless it has one of these conditions. Unless x is in the denominator of this fraction, the bottom half of this fraction, or x is underneath a square root. So is x in the denominator of this fraction? No, it's in the numerator. Is there a square root involved with x in it? No. So, no x in the denominator, so no division by 0. No negatives underneath that square root. We don't have any square roots. So our domain would simply be negative to positive infinity. It's different than 11, because 11, you have an x in the denominator, so you'd have to work with that. This one, though, even though it's a fraction, there's no x down below. So no possibility of division by 0. So we've got 4 questions out of 2-6. Then we'll take a short break, come back, work through all those practice exam questions, and we should have more than enough time for our exam after that. So let's now go ahead and look at 2-6. We're going to look at question 1. And this is, I think, the only kind of difficult question is question 1. Because it involves a fraction. So we've got a function, a polynomial function here, and we want to find now f of 1/4. So the setup is not going to be difficult. Okay, plugging the values in is not where we struggle at. It's probably combining and simplifying everything down. So plugging in our values, if we want to find f of 1/4, we just plug it in. So we have minus 5 times 1/4. We've got to square that. Plus 6 times 1/4. Plus 5. So you've got it all written out. Now, where you may struggle is working and dealing with these fractions. So all the fractions are going to be worked out over here on the right-hand side. And over here, we're just going to start copying things down. So first, how do we square this fraction? Well, if I want to square 1/4, the easiest way to deal with that is to simply write it out. And then multiply, which that gives you 1/16. And you can combine several steps together if you want. I'm going to do them individually so we don't get confused and lose track of things. Now we need to multiply. We did our exponents first, which is order of operations, the correct way of approaching this one. Now we multiply. Okay, so when you multiply, remember this is like a 5/1. And minus 5 times 1, that's a minus 5. 1 times 16 stays with a 16. The next one, we can reduce, or we can just keep it the way it is. It doesn't matter, because we can reduce this down with the 6 and the 4, or we can just multiply. We're going to have to combine these fractions together later anyways, so let's just go ahead and multiply. we can reduce, but we'll just have to bring it back up later. So let's just go ahead and multiply. 6 times 1 is 6. 1 times 4 is 4. And now we have a plus 5, and we're going to make that a 5 over 1. And again, I could have wrote that down as 3/2. Same thing, not going to be a difference. Because we have to get a common denominator. We can't clear the fractions because we don't have an equal sign. But what we can do is combine them together. So what would the least common denominator here be? Well, our largest denominator is a 16. So let's try to make sure that everything is over 16. So we'll multiply this one by 4 over 4, and this one by 16 over 16. So minus 5 over 16 is our first one. And then we've got 4 times, that's 6, that's 24. Over 16. And then 5 times 16, that should be 80, I believe. Yep, that's 80. Over 16. They all have the same denominator. Add them together, and we're done. So 24 plus 80 minus 5 makes it then 99 over 16, and that is f of 1/4. That's it. Where I imagine that we struggled at was just dealing with the fractions. One very, very, very important thing that we need to make sure we recognize is with these signs. Why is this part right here negative? It's negative because that 5 is out in front, not with the exponent. It's out in front, and it's negative, so it comes down. If that negative would have been inside, it would get squared out and become positive. I know it sounds like it's something we remember and we know, but in the past, when you've got a question that has a negative 5 out in front, I've seen students make that mistake and see the square there and associate that with that and make it positive. So I want to make sure that you see the negative comes down. If it's inside, it becomes positive when you square it. So be very, very careful with the signs. I don't want you to miss a question on your exam because of a sign issue. Five. Question 5 is simply graphing and getting the domain and the range. And we're going to graph this function, and when we graph this function, we can replace that function notation, that h of x in this case, with the y. So that becomes y equals minus 6x. Now, how would we go about graphing this? Well, when we go to graph this, we need a slope and we need a y-intercept. But there's no number on the end, is there? Right? So we don't have to, but sometimes I just write it as a plus 0. That makes it a little bit easier. Now we can clearly see that my slope is a negative 6 and my y-intercept is the origin at 0, 0. Now we can graph it. We do not have to check any of the regions because this is an equation, not an inequality. So all we have to do is graph it. And we're going to start at that 0, 0 right here. And then we're going to have to go down 6. So down 6 units, and then over 1 unit. And so that would be approximately 1 comma negative 6. Connect them together. And there it is. When I check your homework, what am I looking for? I am basically looking for a line that goes through that 0, 0. And I want to make sure that it goes down from left to right. So make sure it goes through the origin right here, and it goes down from left to right. That's what I'm going to be looking for more than the slope. Just make sure that it goes down from left to right. If yours is off a bit, that's okay. Make sure it goes down. Make sure it goes through 0, 0. Now, what about the domain and the range? Well, on all diagonal lines, your domain and your range is always the same. And on all diagonal lines, your domain and range is negative to positive infinity. Vertical and horizontal are different, but all diagonal lines, same thing with 4, is going to be a domain of negative to positive infinity, and the same for the range. Okay. I picked question 8 because question 8 is something that we're going to see in the later chapters. And I want to make sure we already know how to handle foiling something out. So question 8, we've got f of x equals 4x squared minus 4x plus 6. And I want you to find f of k minus 1. And we're almost ready to take a break. We'll take a break after we finish this question and question 10. So just a couple more minutes here. What do we want to do? Well, we want to first replace that x with what? We want to replace that x with the k minus 1. So that's what we do first. So we go through and we just rewrite this. And everywhere we see an x, we plug in a k minus 1. Now we need to condense this down as much as we can. So, just like the fraction one that we did in question 1, the exponents go first. And we've got a k minus 1 quantity squared. And that is, writing it out, k minus 1, k minus 1. When we get to the later chapters, the next chapter, which is I believe 4, because we'll skip 3. When we get to chapter 4, we're going to talk about polynomials and how to FOIL them out, and how to multiply and divide them. So k minus 1 quantity squared is wrote out, and now we're going to have to FOIL. So how do we FOIL? Well, we take the first times the first. K times k is k squared. We take the outside times the outside. K times a negative 1, that's a minus k. Inside, another minus k. And last times last, watch your signs. Negative times negative makes it positive 1. So then that is now k squared minus 2k plus 1. Order of operations says we do the exponents first, which we did. Distribute that 4 through. Distribute that negative 4 through. Watch your signs here. And then we'll clean it up after that. So now we've got 4k squared minus 8k plus 4. And then we've got a minus 4k. Negative and negative makes it a positive 4 and a positive 6. So now 4k squared, gone. Minus 8k, minus 4k, those go together, making it a minus 12k. And then we've got 4 and 6, which is 10, plus 4 more makes it 14. And that is going to be f of k minus 1. So we plugged it in, cleaned it up, and wrote our answer down. And we're going to do a lot more foiling next week. Question 10. We're plugging the value 0 in. So we're going to be plugging in 0 into this function. And all we do is we replace the x with the 0. So we plugged in our 0. Now, 0 squared is still 0. 3 times 0 is still 0. So that condenses down now into 0 plus 3, which is simply then 3. So f of 0 is now what? Is now 3. So let's take a short break. We're going to come back. We're going to work on that practice exam quickly, and then take our exam after that. So let's take a short break. Let's just take about a 10-minute break. That we've got plenty of time for our exam. So let's meet back here at, how about 9:35? So take about a 10-minute break. Meet back here around 9:35.